In the previous video, we saw a book and a piece of paper drop simultaneously, and we saw that the book hit the ground first. In fact, much before the paper hit the ground. In this case, we're going to do the same experiment, except we're going to first place the paper on top of the book and see what happens. Well, it's quite a different result, and if we go back and watch in slow motion, we can see that they accelerate at the same rate. As the book falls, the paper falls with it, so as soon as the book hits the floor, the paper is right there hitting the floor as well. Well, what's the difference in this situation from the previous one? The difference is that we've effectively eliminated the air resistance. As the book falls in this case, it kind of pushes the air out of the way, so there's no air holding up the paper. The reason we said the paper accelerated at such a lesser rate than the book in the previous example was because the air was pushing up on it. Allowing the book to fall first cancels out the air pushing on the paper so that the only force acting on the paper is gravity. And we can see that when that's the case, the very, very light object of the paper will accelerate the same as the heavy object, the book, because there's no air holding it back. And this makes sense from the perspective of Newton's second law, which tells us that the acceleration is proportional to the net force and inversely proportional to the mass. And for the paper, when there's no air pushing up on it, the net force is just the weight. And we know the weight is just mg. And so we can cancel the masses, and we see that the acceleration of the paper, in the case where there is no air to hold it up, is simply g, the acceleration due to gravity, 9.8 meters per second per second. Doesn't matter what the mass was to begin with, whether it was heavy or light, it's going to accelerate at the same rate because the masses end up canceling out. Now, this is only the case when there's no air resistance to contribute to the net force. So by letting the book fall in front of it, we are effectively canceling out that air resistance on the paper, so we can see that it accelerates at the same rate as a heavier object.